Okay, guys, thanks for joining. Okay, Simrit also here. Hi, Simrit. Can you hear me? Simrit.
Hello.
Hi, ma'am. Go ahead. Just introduce yourself, one or two words about you and what is your skill set and all currently.
Okay. Hi everyone. My name is Simrit and I'm currently in Toronto and I was working with Scotia Bank for their SAP implementation and support projects. So primarily I'm into SAP HR with experience in recruitment side as well. And qualification wise I'm an MBA IB and currently looking for new technologies and getting into new market.
Okay. Thank you, Simrit. Thanks for joining. So it's great to see you all here. Yeah, let me go ahead and introduce myself. This is Shiva. So I have total 10 plus years of experience. Okay. And out of that, I started my career as a Java developer. Then I worked as a mainframe developer. Then from last 4 years, 4 plus years, I'm in data analytics. Okay. So I'm working as a big data. I'm working as a big data developer from last 4 years. Okay. So and apart from this one, I do have a classroom training experience within my organization. I've trained more than 1,000 plus people within the big data. I'm not talking about other thing, only within the big data. I've trained more than 1,000 people within my organization. And on classroom training, this is my 28th batch. 19th batch already running. This is my 28th batch that I'm taking on the online one. So this is my relation with my RS training. RS training is not only famous for your Hadoop, it's for everything. So it's a great place to learn. Since you are here, we are going to see each and everything, how we are going to take you into the big data and how we are going to, what is big data and what is the purpose of having the Hadoop and all, we are going to see very thoroughly. Any questions before we start our the demonstration?
Okay, so just a quick one, like I have no experience within big data analytics or Hadoop or any specific related database models. So is that okay for someone like me?
Yeah, the prerequisite for learning this big data Hadoop is we don't need anything. All you have to know just E0 level of Unix and as well as the SQL knowledge. You don't have to know Java. And if you don't want to be proficient in ABC echo component that we are going to discuss.
Okay.
Hey Shiva, I have one question.
Yes.
So how this course gonna be like? It's you gonna show all real-time concepts and all, and after this course we gonna clear our certification and all. If you are interested,
Yes, we do have a
interested like.
certifications available from RStrainings, and apart from that, we are going to use real-time use cases, real-time examples that I'm dealing day to day in
Not
my.
from RS training. I'm talking about this Hadoop certification will be there, right?
Oh,
Some
you mean
part-on works.
yes? So
Yeah, yeah, yeah.
if you are going for a certification externally, the the
Mm.
concept that we are going to cover within our training is going to help you out to take the certification also. For my previous students, they were able to clear the certifications. The way we are going to cover the topics that we are going to cover is they're going to help you out to take the certification also.
Mm.
Okay,
Yeah, yeah.
guys.
Because I'm
Hmm.
for the time.
Yeah. And also this class will be recorded every day, and after the completion of our session, we are going to share with you all your email IDs. So at max, somehow you're not able to meet the class, and the next day you're going to see that recorded class in your email block. So you can replay that one and you can come back with your questions in the next day. It's a maximum. It's a least worst case I'm just talking about. Okay, so let's go ahead and discuss what is big data. What is data set? Generally, data set is nothing but if you are putting related information or collection of related information. If you are putting together, we will be calling that one as a data set, right? So what is big data set? Big data set is nothing but collection of large data sets. We'll be calling this one as a big data set, or it is a data set which is impractical. Okay, not impossible, impractical. I use two words, so be very careful here. Impractical to store or to process the data set using existing computational algorithms. Whatever algorithms that we have, it can be C, C++, Java, or whatever is using them, we are not able to store. It is impractical. We are able to store, we are able to process, but we are not able to do that on time. That is called, it is a big data set. That is one more definition for the big data set. Okay, so as you know, earlier we used to get bytes, KBs, megabytes, gigabytes, right, and also terabytes. Now we are seeing petabytes and zettabytes, exabytes also we are seeing. So we are seeing this much of data currently we are seeing in the market. From where we are getting? We know that from different sources. As you know, every day how much data that you are processing, you know that. I mean, if you see, till 2009 we used to have in around 1.9 zettabyte of data. Now it got increased like anything like 2.9 zettabytes of data. Till 2007 this was the data that we used to have. Now it's dramatically created like data anything, because how we are getting the data, we are going to see from where we are going to get the data, but using some of the V's also we can define. I mean, till this point of time we are able to do the data analytics using our existing computational techniques, but from this point of onwards, probably till terabytes of data we are able to process using the existing computational techniques, but from this onwards we are not able to. It is impractical to store and process the data set using the existing algorithm. So that is the reason we have Hadoop kind of technologies in the market. Okay, so what is this Hadoop? Why we have to use Hadoop kind of technologies when you have when you are going to deal with your big data? So Hadoop is a open source framework which is written in Java. It's an open source framework, okay, which is written in Java, okay, on Linux platform, which is intended to resolve the big data related or address the big data related issues, okay, in terms of storage wise, whatever we have seen, and in terms of processing wise also. That is called Hadoop. Hadoop is a open source framework which is written in Java on Linux platform, which is going to address the big data related issues in terms of storage wise and processing wise. So let's go ahead and define what is this. I mean, why we are not able to process using our existing computational techniques. As you know, we are getting the petabytes of data, large volume of data. As you know, big data can be defined in using some of the V's: volume of data, okay, velocity of data, variety of data, and veracity of data. So these are the four V's. Using this one we can define the big data. And if you take any organization, that organization is going to have the organization data is going to have this kind of characteristics. Okay, let's go ahead and see. Volume of data means the amount of data that we are going to add to the warehouse from the data source is called volume of data. Okay, any questions here? So how we can define what is the volume of data? The amount of data that we are going to add to the warehouse from your data source. It can be anything. It can be your Facebook, it can be your Google, it can be your telecom data, or it can be just, you can take the wherever you are working, just take that one as an example. The amount of data that you are going to add from source to warehouse will be called as a volume of data. This volume of data nowadays got increased like anything in terms of terabytes, in terms of petabytes. Also we are getting the data in terms of every day or every week or every month. So we are getting the petabytes of data from our data sources. That is the reason it is impractical to store or to process using the Java. They're good to do with your data analytics, not with the big data analytics. They, when they were designing these products, they did not think like we are going to see this much of data, we are going to see this much of data in future. That is the reason they did not address that issues when they were developing those products actually. Then what is velocity? Velocity is, yeah, we are trying to add these petabytes of data or terabytes of data at what speed? Okay, at what speed we are adding the data to the data to the warehouse. This is called warehouse. Is nothing but anything. You can think like your MySQL thing, or you can think like your any database. You can think at what speed you are trying to add the data to your warehouse. It can be probably within a week, in a week, or in a month, or in a year. So at what speed you are trying to add this much of data? So nowadays, if you take any example, for example, the plane is trying to fly from India to United States. By the time it started and reaching the United States, it's generating terabytes of data, around 15-20 terabytes of data. That is called speed. It within a one day or within 24 hours, it is trying to generate this much of data. We have to analyze the data in order to come up its analytics, saying that at what time it is reaching, what is the temperature over there, and how it is flying, or how much it's going to be the delay. Those, all these things will be analyzed or will be coming into the picture by analyzing the 10 terabytes of data. That is called velocity. Then what is this variety? So as you know, if you take any data, we can divide the data into three ways: structured, okay, semi-structured, and unstructured data. So what I mean by structured data, you know that one. What I mean by structured data, whenever your data is in a rows and columns, your data is designed in the rows and columns, that time we'll be calling that one as a structured data. So what I mean by semi-structured, only halfway we have given the meaningful meaning to our data. Is a organized your data in a halfway. The best example here is XML file, or your JSON files, all are like your semi-structured. Then what about the unstructured data? What about the unstructured data? Unstructured data is the one which is not going to have any structure. The best example here is text files, or audio files, or video files, whatever it is, or your sequence file, whatever files you can call, those are like unstructured data. So we are getting this kind of data every day from different sources. It's not only, earlier we used to get only the structured data. That is the reason we used to do our data analytics very easily. But nowadays we are getting different variety of data. Mostly we are seeing unstructured data. That is the reason we are not able to process the data using our existing algorithm. There is one more drawback, or one more thing, how we are now, why we are not able to process the data using our existing computational techniques. The last one here is the veracity. So for example, you are getting 100 terabytes of data from your data source, but out of this one, which one is valid for you to do your further data analytics? For example, if you are taking the banking sector, every day you are going to see lot many transactions, lot different data you are going to add to the data warehouse. But out of that, you would like to just process only the data that is related to banking transactions or ATM related transactions. In that, you have to separate out of your 100 terabytes of data, you have to separate probably 1 terabyte of data that is related to your transaction related data out of your ATM. So indirectly you are going to separate out of 100 terabytes of data, 1 terabyte of data which is valid for your data analytics. You are going to separate that one. So remaining 99 terabytes of data, it will be useful for your other data analytics purpose. It's not something it's going to be, we are going to we are not going to use that one. But for my data analytics, currently I am going to use only 1 terabyte of data. That is called veracity. Extracting the valid data out of your raw data is called veracity. So your data set, whatever you take now, currently any data source, it's having high in volume, high in velocity, high in variety, high in veracity. So that is the reason we are calling this one as a big data, and we are not able to address these big data related issues in terms of using your any existing computational techniques. That is the reason Hadoop kind of frameworks came into the picture. Let's go ahead and see why we have to use Hadoop when you have Hadoop kind of technology in the market. Any questions so far? Any questions so far?
That's okay, pretty understandable.
Thank you so much. Let's move on further. So we have discussed very thoroughly what is big data. Big data, you can see from different sources, from Go Global is the evidence, like within 60 seconds how much data they are creating from the different data sources, YouTube, and how many new domains are getting registered, how many emails are being sent, how many new searches are happening. This picture clearly shows within 60 seconds, which means within 1 minute of time, which has a high volume of data, high velocity of data, high variety of data, high velocity of data. So that is the reason we are not able to address, we are not able to store or process the data on time with the given technologies currently whatever we have in the market. Okay, this we have discussed very thoroughly in now. Okay, this definition is very important for your certification as well as your interview purpose. They might be asking define. So nowadays Cloudera and Autonworks is going to ask you in the write up, not just going to ask the question answers. Okay, so they might be asking the define the big data. This is the definition that we have given from the IBM side. Okay, this 4 V's, the definition given from the IBM side. Okay. So then now let's go ahead and see why we have to use Hadoop when I have Hadoop kind of technologies. So Hadoop can collect the data from different sources, which means so you can go ahead and collect the data from satellite, okay, or from sensor data, or from the GPS kind of thing data, from your content management, or from your system logs, networks logs. So from different sources, it can go and collect the data. Hadoop does not have to use the different framework, or does not have to use the third-party tool to collect the data and to process the data within the Hadoop. So using Hadoop itself, you can connect to the different sources, and you can collect the data, live data and streaming data, or the batch-oriented data then and there, and you can process the data. So that is the reason we have to go and use Hadoop when you have big data related issues. The next option that we are going to have here is Hadoop is going to do the best for the batch analytics. What I mean by that one here is, for example, if you are taking monthly bills. So as you know, if you are going to have generate the monthly bill, you are going to accumulate. Okay, you are going to accumulate for 30 days. For 30 days data, and on the last day you are going to run the programs to create the bill. So this is the bill that you're going to do, that one, that the programs that you're going to run on the 38th day, that is called batch oriented. If you're not sure about the batch oriented process, this is the example. So for 30 days we are going to collect the data, and 31st day we are going to run the programs to create the bill. That is called batch oriented, which means we are going to we are going to collect the data over a period of time, and we are going to run. It can be monthly, it can be weekly, it can be end of the day, it can be end of the hour, whatever it is. So that is called batch oriented. The next feature that we have is the real-time analytics. Your Hadoop can do the real-time analytics also. The best example here is fraud detection. Okay, for example, you are swiping your data somewhere, your card somewhere else, and you have to validate that one with a valid transaction or not. So out of your big data, you have to process the data, and you have to make sure that is a valid transaction or not. Your Hadoop can do it. Then and there it can process, and it can detect whether it is a valid transaction or not. That is called online transaction, online batch processing. Okay, so that is the best example where we can do the batch as well as online analytics, okay, using our Hadoop framework. The next one is the predictive analytics. What I mean by predictive analytics here is you can predict what is going to happen based on by analyzing the raw data that you have in your warehouse. For example, if you are introducing any new product, if you are going to address anything about from the customer complaint, so what is going to happen if you are going to propose so and so things. So those kind of things can be addressed, or can be do the data analytics using our Hadoop. And the first and foremost very important feature is Hadoop can store the data in a commodity hardware. So what I mean by commodity hardware here is, let's go ahead and discuss now enterprise hardware. So what I mean by enterprise hardware here is, whenever you go with the enterprise hardwares, you have to use, you have to spend a lot of money. So whatever we use the enterprise hardwares here in our production grade environment, if you take Java mainframes or any .NET related for technologies, you have to use the enterprise softwares as a hardware for them to run, because they are the high reliable hardwares. Okay, high reliable hardwares, which means they may not go down very frequently, but obviously you have to spend most. Okay, you have to spend lot of money for this one. So in order to buy probably 1 terabyte of capacity, you have to pay around $5,000. Okay, I'm not talking about rupees. $5,000 we have to spend to just buy the 1 terabyte of data in terms of enterprise infrastructure. Whereas if you are going with the commodity hardwares, you have to spend only less amount of money. So with the sense, as you know, whatever you are using in our personal computers, these are the commodity hardwares, which means cheap hardwares, low reliable hardwares. They are okay, they may go down anytime, but for that, how much we are paying for 1 terabyte of, to buy 1 terabyte of hard drive, you are paying hardly $100, now 150 maximum. So that is the difference between the enterprise hardwares and commodity hardwares. The commodity hardwares are the low reliable hardwares, but using the commodity hardwares only we can store the data. Then how, Shiva, then you are going to say we are going to store the data in the commodity hardwares, low reliable hardware, then if the system is going down, how we are going to recover the data? Yeah, using some concepts, we are going to recover the data automatically. Our Hadoop framework is going to recover the data within our another framework. So that is called commodity. So we are going to use that feature out of our Hadoop, and we are going to address this fault tolerant. This is called fault tolerant. So we know that we are going to store the data in commodity hardware, that system is going down, but how we are going to address that one? So using the replication factor, or using the by having more than one copy within your system, we are going to address this issue. Okay, so these are all our features are there, and you can scalable. Now, one more thing here is scalable, which means how much, for example, if you want the more processing capacity, you can just go ahead and add one machine to your system, or if you want the more storage capacity, you can just go ahead and add one more machine to your system. So that is called, which we are going to see here, parallel processing is the one that we are going to discuss very thoroughly now. But as of now, this is scalable. I mean, as you know, if you are existing techniques, you cannot add how many systems that you want. You cannot go ahead and add this one at given point of time. It cannot be, there is no way you can go ahead and add more systems to the systems. Okay, that is the reason it is not scalable. Probably 50 systems you can add, after that 50 servers, where I say machines or systems or servers. Okay, you can add 50 servers, after that you may stop adding that, because your system is not enough capable to put the data all together and process that one. So that is where we stopped. It's not a scalable system. But if you are going with Hadoop, it's a scalable, which means how many machines that you want, you can go ahead and add. Okay, let's go ahead and see how the Hadoop framework is going to work. What is the architecture of our Hadoop? So before that, any questions here?
Okay. There is this first point that you mentioned. One second. Collect the data, that this first thing.
Okay.
So I want to know a little bit about this GPS CMS. So this is like as an example you mentioned, or
Yes.
this is the standard thing?
As an example, you can go ahead and collect the sensor data, like if you are having any, probably if you take the oil industry, so they're going to take the oil from oceans and all. They're going to send some sensor related data to that system where it is going to collect. So instead of going and taking the data, carrying the data and plugging into your systems, you can collect the data then and there from there, and you can process the data where you are sitting here, so that your
Okay.
Hadoop framework can connect to that sensor and it can collect the data. And the next thing is
Okay.
GPS. So as you know, in United States, probably you might have seen the trucks are going to use some GPS kind of systems where it's going to track its truck speed or driver violation or weather condition, and at what speed it is going, and at what location it has stopped, how many hard brakes it has given. So those kind of things can be captured using our Hadoop directly.
Okay,
And the
got it.
CMS, content management system, is like your Apache server log or your different servers log. You can go ahead and collect the data, your mail server, Apache server. So these are the servers log. You can go ahead and collect the data. As you know, whenever you are going to access or do any activity on top of anything, you are going to create lot of data in the background. That is called access log data. So you have to make sure that you can go ahead and collect the data, and you can do your sentimental behavior kind of thing, how this user is acting, why this user is coming into this my application and is trying to browse that one, is not going to check out anything, all the way he has added the products to the cart, but why he did not do the checkout. Those kind of sentimental analysis can be done by capturing the activity data out of your server.
Okay, all
Okay,
right.
and the system logs, as you know, the just example like your mail servers or your normal system log, whatever is the best example yearly, like our access log. Okay, and also network logs, like as you know, when you are going to have the huge system, very complicated system, so you have to make sure your all systems are up and running, or your what and all fluctuations is happening, or how your networks is happening, which system is down. So those kind of things can be done using your network log system also. Clear?
Okay, all right. Yes.
Okay.
We have an enterprise and low commodity hardware, right, Shiva?
Yes.
So how is this to store in commodity hardware? I mean, those are very important big data related to some maybe industry or something like. So how safe is it to store in commodity data hardware?
Excellent question, that one. So now our first of all, our Hadoop architecture is going to be the master slave architecture, which means one work computer will be acting as a master and the rest of them will be working as a slave. So this is how architecture will be. Okay, just see here, these computers, all computers will be connected within the network. Okay, so this will be, we will be calling this one as a cluster. Actually, if you are putting more than one computer within the network, so that time we'll be calling this one as a cluster. So this is what Hadoop cluster, we can say this one is a Hadoop cluster. So this is a master machine, and this is my worker machines, worker machine 1, worker machine 2, worker machine, sorry, worker machine 3. So we have different names for this one. So as we go on with our classes, we are going to introduce those terminologies. Don't worry, I'm just using that as a machines, it's okay. So now I have connected 4 machines as a worker machines to my master machine. Master is the one who is going to, whenever you wanted to store any data, you have to go with the help of your master computer. Whenever you wanted to process the data, you have to go and with the help of master only, you have to do that one. For example, whenever I wanted to store any data within my Hadoop cluster, for example, it is having around 1 terabyte of data or 4 terabytes of data, I have the data. So now, as you know, here we are going to use the master slave architecture. My master computer is going to divide my entire data into 4 parts actually. Okay, how it is going to divide, that is entirely for our Hadoop framework, just leave it up, but just to try to understand the concept here. So now I have 4 terabytes of data. I'm going to divide into 4 parts, and my master computer is going to do that one, and it's going to divide, and it's going to store one each piece into the single computer. One piece, 1 terabyte of data here, and 1 terabyte of data here, and 1 terabyte of data here, and 1 terabyte of data here. So 4 terabytes are distributed into the 4 computers. So now whatever the storage issue that we have here, we have resolved using the Hadoop framework. How? Instead of storing into the single computer, what we did, we distributed the data into the 4 computers, right? Any questions here? We distributed. If you want more storage capacity, simply I will go ahead and add one more computer to my system. That's all.
Is it 1 terabyte divided into 4 systems, or for 4 terabyte a replication of into other workstations?
Yeah, I'm going to do that one. So now just this data size is 4 terabyte. Just think like this data size is 4 terabytes of data. Okay. So now we are going to divide into 4 pieces. So each piece is going to have the 1 terabyte. So that each piece is going to store in a single machine that will be taken care by my master computer. But as we know, we are saying this is a commodity hardware. That is the reason how many computers that you want, you can go ahead and add. This is a cheap hardware. I mean, I don't have to spend a lot of money to add. I mean, for my organization like Yahoo or Google or probably Facebook and all, adding these cheap computers are like anything for them. I mean, it's very negligible amount for them. So in this case, for example, this machine is going down. Obviously, we are saying these are commodity hardwares, and whatever we stored the 1 terabyte of data out of these 4 terabytes of data, that is gone. I mean, we may not able to process the data. Okay, by the way, before we just address that one, okay, whenever you wanted to process these 4 terabytes of data, you're going to write the logic same as how you're going to process when you store your these 4 terabytes of data in a single machine. How you're going to process the data, the same way you're going to write the logic, and that logic will be sent to the master computer. Master is the one who is going to send the same piece of data to here. Okay, the logic will be sent here, so it is called the data locality. Your code is going where your data resides. Actually, that is called data locality, which we are going to see very thoroughly. I'm just giving the high level one. If you have any questions here, just try to, you can ask me now, but try to understand here. Whenever you wanted to process this one, okay, when we write the logic, when we send that logic to the master, master is the one who is going to send the same logic to work on top of this chunk of data. This is only the chunk of data out of the 4 terabytes of data, right? It's not the whole data. So this chunk of data will be processed by this computer and this computer and this computer and this computer, and we are going to see how we can aggregate this all data together, and we are going to see the final results here. Who is going to aggregate? This machine is going to send the results back to this machine saying that, okay, I have processed this one and these my end results. I process this one, these my end results. I process this one, something like that. All your worker machines are going to work on your individual chunk of data, and your master is the one who is going to consolidate the final results. Okay, and is going to give the final results back here. So here we included the 4 terabytes of data, and we process the 4 terabytes of data, and we see the final output. Instead of just processing the 4 terabytes of data out of your single machine, what we did here, and we seen for I mean, you have processed the 4 terabytes of data using single machine, and the same logic you applied on top of this one, and you have seen your final output. The same way here also, we process the 4 terabytes of data using 4 different machines, and we have seen our final output. Okay.
Okay. If it is like workstation 1 is failed, we have other than three work machines are working. But if we are losing work machine 1, right, which means we are losing 1 TB of the valuable data, right?
That's correct.
Then I mean,
That's correct. That's correct. Excellent question. I'm going to address that one issue. So now, as you know, like he says, yeah, whenever you're going to store the data in the multiple computers, out of 4 terabytes of data, only 3 terabytes of data is available, and this machine is went down because this is a low reliable hardware. It may go down anytime. That's what the nature itself, you're saying it's a low reliable hardware. So that is the reason our Hadoop framework, whenever it is going to store the data, this 4 terabytes of data, when it's going to divide into 4 pieces, instead of storing one time, it's going to store 2 more times extra. So total it's going to have the 3 copies. For example, here 1 more terabytes of data, and 1 more terabyte of data, and 1 more terabytes of data, probably from 1 more terabytes of data here. So now, for example, for the first 2 terabytes of data, I have stored here and here and here. So now if this machine is going down, still I have 2 more machines are available to process that 1 terabyte of data, right?
yes.
This is called replication factor. At the time of storing your data into your Hadoop cluster, your Hadoop framework is going to store more than one time. Okay, but how Shiva, I mean, 4 terabytes of data itself, we are talking about the big data. Then you are going to store into 3 times, means 12 terabytes of data that you are going to add. Then how you are going to do that one? Okay, that is very simple. As we know, these machines that we are going to add is a commodity hardwares. That is the reason how many machines that you want, you can go. That is called, it's also just scalable. How many machines that you want, you can have. In our currently, Yahoo is having the biggest Hadoop cluster, that is having 45,000 machines in their cluster. 45,000 machines. Okay, they have put 45,000 machines together. That is how they have built together. So now you can see we address the failures here. This is called fault tolerant. By having the more data availability, you can just, even though this machine is going down or this machine is going down, we have one more machine. Okay, or probably you have a limited machines probably, and you have only 4 machines, but you would like to process the data. In that case, this machine does not mean that it's going to store only 1 TB of data, right? So I'm going to store one replica here and one more replica here of that one. So if this is going down, this machine is going to act for the my first replica as well as my second chunk of data also. So in mean it's kind of more burden for that machine because you don't have more machines available in your cluster, but this is not the case in the production grade environment. So the more machines you are going to have, the replications that you are going to have is like more than one time. So if one machine is going down, you are going to make sure the other machine will come into the picture and it will be acting, or it is going to be in terms of processing the first machine. You are going to make sure that machine will be acting as a main machine for you.
So in the productive environment, each work machine will be having a 2 replicas, right? What I'm trying to say.
Yes,
In case of
minimum
example,
minimum minimum 2 replicas. By default, your Hadoop machine is going, Hadoop framework is going to have a 3 replicas, which means 3 copies. You are going to see that in 3 different machines.
okay. So every work machine will have 3 copies.
Excellent.
Okay,
Indirectly.
I have one more doubt I would like to ask here. So we have 4 TB of data to be processing. Okay, so not in the case of fault tolerance. We have these 4 machines. I mean, again, these 4 machines have a 2 replicas. Okay, so we for these 4 working machines are working properly, and we need to only process 4 TB of data. So under these replicas can be erased after erased and can be stored under data, like or we have to process this as a 12 TB of data.
No, you can remove the data whenever you don't want to have the data within your this data nodes. This going to have as a kind of this distributed data. So we are going to see more concepts actually. Probably you know a little bit about Hadoop, so you may be getting this one. So we are going to see very thoroughly how your data will be organized in the distributed manner, and how what is the local, what is the distributed one. When you are going to keep any data set in a distributed manner, how it will be distributed. Your data that you are going to store, this 1 TB of data out of this machine, that is not only is going to stick to that machine. It cannot stick to that machine. It can go into the different machine when you are going to start your Hadoop cluster one more time. We are going to see that concept very thoroughly. Okay.
Okay.
Okay, don't worry about
Okay.
that one. I am here to make sure everything clear. I'm going to explain the concept. Once you are clear with that one only, we'll be moving on further. Now or tomorrow or today, back and forth, because probably the question that we might be asking is like we need to cover more topics. So in that case, I'm going to give you the high level one, but definitely I'm going to cover probably after one day or 2 days, because we need to cover some more topics to address that question. In that case, I'm going to tell you high level one, but at any cost we are going to cover that one on it. And end of the course, you should not be having any question out of the Hadoop saying that okay, this is how it's going to work out. No. Okay, so this distributed concept in our Hadoop, we will be calling this one as a HDFS, Hadoop Distributed File System, HDFS. And the processing, whatever we have seen the processing, we'll be calling this one as a map reduce. Okay, HDFS is going to be talking about the storage, how you are going to store the data, big data, and the map reduce is going to talk about the programming language, how you are going to process the big data. Using these 2 core components, whatever issues that we have out of our Hadoop, we are going to, out of our big data, we are going to address HDFS, Hadoop Distributed File System. Okay, this will be used for issued resolved you for your whatever you have the storage wise, and map reduce programming techniques, this one. Okay, using which you can process the large data sets. Okay, in terms of big data. Okay, indirectly it's a big data. Clear? We are going to discuss very thoroughly on this one. On top of that one, we are going to discuss HDFS and MapReduce will be covered very thoroughly. On top of that, we are going to discuss PIC. PIC is a alternative abstraction on top of the MapReduce program. It's a alternative. Okay, what I mean by alternative of MapReduce, as you know, if you want to write the MapReduce program, you have to know Java or you have to know basic Java. I'm talking about basic Java or C++ or Python or Ruby on Rails, whatever programming language that you have to have in order to write the MapReduce program. As you know, people are like who are having this knowledge in the market are very less. That is the reason they came up with the pig. Pig is the alternative abstraction on top of your MapReduce program, which means pig is going to use pig Latin scripting language. It's very scripting language. It's very simple one. Okay, very simple. Within 2 to 3 hours you can learn. You can start coding that in the production. That's the logo that we have for the pig. It's very simple. We are going to learn that one. This pig Latin scripting will be converted into series of MapReduce programs, and it's going to work on top of my HDFS file system. So okay, as a pig developer, if I'm going to portray myself as a pig developer, I don't have to know about Java. Even I'm not going to touch at all about Java. And we are going to learn the pig Latin. And also we are going to see advanced concept about out of pig UDFs. Okay, UDFs are the very important user defined functions. Okay, we are going to see these advanced concepts out of our classes also, and also we are going to see pig joins also. Okay, we can join more than one data set together using your pig. Actually, it's very easy. Joining two data sets are very easy using your pig than your MapReduce program. We are going to see all these things along with the use cases for each and everything that I'm going to explain these concepts, MapReduce, HDFS, pigs, and everything. We are going to see the use cases, real-time use cases, along with the examples that we are going to see day to day. And also the next echo component that we are going to cover is Hive. Hive is a structured query language, same as SQL. Okay, and we are going to, it is again kind of alternative for your MapReduce program. Instead of writing your lengthy MapReduce program, you can just if you have the E0 knowledge about SQL, you can just go ahead and start working with the Hive. Okay, within this Hive we are going to see, okay, Hive partitions. It is a Hive partition is the way we are going to partition our table. We are going to see very thoroughly. Then Hive buckets also we are going to see. It's an advanced concept. The way we are going to manage the data within your tables. We are going to see the bucket concepts, and the Hive UDFs also we are going to see. So Hive and the pig are going to work or execute exactly the same way. Pig is developed by Yahoo, and Hive is developed by the Facebook. They're going to work and they're going to execute the same way. And the next thing is we are going to see HBase. It's the next column oriented database. We are going to discuss very thoroughly about this one. Okay, instead of, probably you might have seen while you're storing the data in the MySQL, we have to have probably millions of instructions. If you want to store the billions of instructions, we cannot do that one. But using HBase, it's a NoSQL database. Using that, you can store the billions of records. Okay, you can store the billions of records in this one, and you can fetch easily within a fraction of seconds. That is the power of your NoSQL. We are going to see very thoroughly about the NoSQL database, which is a HBase, and also we are going to discuss the next thing is Scoop. Scoop is a ETL tool out of our Hadoop framework where we can extract the data from RDBMS databases into RDBMS databases to Hadoop. Actually, you can extract the data and you can put. Scoop is nothing but SQL to Hadoop. So name itself it says SQL to Hadoop, which means from your RDBMS databases, and you can keep the data into your, you can import the data and you can export the data back to RDBMS databases using your Scoop. It's a very small echo component. It's very powerful, and it's going to be have a lot many features, but it's very small echo component. We are going to discuss very thoroughly out of your Scoop. We are going to discuss incremental imports also. Okay, incremental imports also we are going to see very thoroughly. What I mean by incremental imports here, it's an advanced concept where today probably you have 100 terabytes of data within your database, and tomorrow you might be seeing 110 terabytes of data. So whenever you wanted to import the data again, those databases into your Hadoop framework, you don't have to do again the previous 100 terabytes of data. You have to just to do only 10 terabytes of data. That is called incremental imports. If you're not sure about that one, incremental imports also we are going to see very thoroughly type of incremental import, and we are going to have the hands-on. We are going to have the software, and we are going to do the hands-on within the class, and as well as I'm going to give the use cases for you also. And also we are going to see the Flume. Flume is again one more ETL tool from logs, actually, like system logs, network logs and all. Using your Flume only we can extract the data and we can put it in our Hadoop framework actually. Okay, you can use the Flume echo component, using which you can extract the large log files and you can put it into your Hadoop framework. Okay, and also on top of all these things we are going to discuss very thoroughly. Okay, we are going to discuss about the use cases. Okay, use cases, and also we are going to see the installation part. Okay, installation parts of all these echo components. Okay, ecosystems we are going to see very thoroughly, which means we are going to cover 20 to 30% of admin classes also here. Okay, so once you complete my courses, you are going to see like installation part of each and every component, how to do your Hadoop cluster, single node installation, multi-node installation, and all echo components. Echo component, which I mean ecosystems in the sense pig, hive, HBase and all. You are going to learn all these things, how you are going to install on your machine. So indirectly we are going to cover 30% of our admin classes also, how to do some of the settings also, how to do some of the configuration settings, security related things also we are going to see very thoroughly in our classes. Okay, so this is what we are going to cover. On top of this one, as a add-on, we are going to have, these all are related to Hadoop. So Hadoop is going to have some kind of concerns. It is going to work with the big data, okay, in the kind of batch oriented way as well as online oriented way. As you know, we got one more version where we are going to use one more methodology where we can work on top of your data, that is called Spark. Okay, Spark is the one, it's going to use aggressively your memory, in memory buffer. You are going to use very aggressively that one, and we are going to see Spark very thoroughly using in our classes. Okay, Spark, and what is Spark core, and Spark streaming, and also we are going to see Scala also, what and all required for required programming language, programming skills to develop. Okay, Spark application we are going to learn Scala also. Scala is a functional programming language. How we are going to use Java, C++, Ruby on Rails to write our MapReduce program, we are going to use Scala is a functional programming language using which you are going to write the Spark application. Spark is only the processing component. It does not have the any intelligent to process. You have to use one of the technologies in Scala or Java or Python or whatever it is. We have to write in terms of this programming program only in order to write your Spark application. So we are going to learn Scala, and also we are going to run Spark streaming, Spark Spark streaming, Scala also we are going to learn. On top of that, we are going to learn Tableau also. Tableau is a business intelligence tool using which you can create your graphs easily. You are going to visualize your data in a graphical way. So we are going to see how to install your Tableau, how to connect from Hadoop to Tableau we are going to see very thoroughly. Okay, and also we are going to see how to connect Hadoop to Spark also, and we are going to see installation of Spark, okay, and Scala, and installation of Tableau, and connecting to Tableau to Hadoop, and connecting Spark with Scala, and connecting with Hadoop also we are going to see. So this is as a package. We are going to get all this, we are going to cover all these things, and make sure, just don't forget, like we are going to cover, or we are going to have the use cases also, which means I'm going to give the exercises for you people, and you have to work on them, and you have to come back with that resolutions on that one. Okay, any questions on
Uh,
this one? Go ahead.
yes, one. Uh, what is the Hadoop software version which we are using right now in the product environment?
Right now we are going to use the stable version that is called 2.7.1 is the latest one, but people are still sticking with 2.5, 2.4, 2.6 kind of. 2.7.1 is the latest version.
And stable one.
It's a stable one. We have 3 version also, but that is not a stable one. It's not mirrorized one. Still it is having in the under the development only.
Okay.
Okay, any questions? Any questions how we are going to cover Krishna and Simrit also?
I understood the bifurcations you mentioned, so it is quite technical in terms of certain things. But yeah, once we go through all these step by step, it will be fine.
Yeah, definitely. Once we are done with our classes or bed, every day we are going to meet 1 to 1.5 hour. So once we meet every day, you have to put 2 to 3 hours of efforts. If you are keeping that
Yeah.
efforts, if you are giving the assure that like you are going to keep that much of efforts once I am done with my class, okay, so you are going to achieve where you wanted. Definitely, I can make sure, I can assure you on that one, because this is not the first batch for me. I know how to train the people. I know how to deal the people. If you have any questions, if you're not able to understand, if you're not very good in Java and all, I can give you the steps. We are going to have the very detailed explanation in our classes on the each and every concept that we are going to discuss. It's not something, if you are not sure about this one, then we can skip and we can see later. But no, first and foremost thing, we are going to make sure that is got what you wanted out of that concept, then only we'll be moving further with our next topic.
Yeah, that's nice.
Okay.
Yes.
Okay, thank you. And any questions before we wind up? And we are going to start our batch soon. Please be in touch with the organizer. So just be in touch with them, and we are going to start our batch soon. Okay, any questions or anything that you wanted to see, like okay, are we going to see this one, Shiva, or are we are going to learn this one, this kind of things? Shravan, you also.
Nothing from Krishna.
Thank you. And Simrit, I hope you are clear. Please go ahead if you have any
Yeah.
questions. And also,
No, I'm fine as of now. Yeah.
thank you. Okay, then thank you so much for your time, and talk to
Thank
you
you.
soon again. Bye. Have a
Sure, sure.
good day ahead.
Thanks.
Thank you. Bye.
You too.